welcome to another tutorial. I want to apologize for not being consistent in my posting new videos because I have been on a course taking neural network course. So I just finished the course and I said let me make my first video on neural network. So one of the beauty of becoming data machine learning engineer is not just knowing one part of it, but knowing the full package of what makes you a good data or machine learning engineer. You need to know scikit-learn and also neural network using TensorFlow or PyTorch. There are other neural network libraries, but the most important or popular ones are TensorFlow and PyTorch. So today I'll be teaching us how to use neural network to make predictions on a data set from Keras. So without further ado, let's dive into a tutorial. So I'll go to my personal folder and I'll locate my tensor. Okay, I'll open it. I'll go to CMD, that is command prompt. I will open my Jupyter notebook. Please stay with me. Alright, it's loading. Alright, so I'm going ahead to make a new project. Alright, so and I'll name this, let me bold it. I'm going to name this, let's say, new NN. Alright, so for neural network. So I will not go with the basics of a neural network in our subsequent videos. If you want me to make a complete tutorial on neural network from scratch, please let me know. But today I want to show us how to create or build your model using neural network TensorFlow. So we are going to, the first thing we need to do is to import our dependencies, to import the libraries we are going to work with. So the first one is import TensorFlow as TF. Alright, from TensorFlow import Keras. Keras is an API that will help us to get our job done faster and to get our data set already prepared for this tutorial. Alright, also from TensorFlow again, TensorFlow.keras. Okay, import what we call layers, data sets and models. Let's go ahead and run our code. If you're running for the first time, you're going to take a bit. Alright, so our code has been, all our libraries have been imported successfully. So the next thing we're going to do is to get our data set. And to get a data set, we say you can use train underscore images. You can name it whatever. Alright, so test underscore labels. Alright, you go out of it, comma, and train underscore labels and test test underscore labels. So here is going to be not labels, it's going to be test images. So equals to our data set which we have imported, data set dot, we're going to use mnis data set dot load underscore data. Alright, let's go ahead and run it. Alright, so we are going to import our data set. How to, if you want to check it, you can say okay, train underscore images dot shape. Alright, so dot shape, want to look at the shape. We have 60,000 and is 28 by 28. Okay, if we say test underscore images dot shape, alright, go ahead and run it. We also have 60,000. Alright, so we can also go ahead and import our library matplotlib. Import to visualize, import matplotlib dot py plot as plt. Alright, so we are going to visualize our image. let's say train underscore images. All right, now you can say plt dot im show. Im show stands for show. What are we going to see? We're going to see this. All right, so we're going to see the first one, the first array of this. So let's go ahead and, all right, so you have seen from our data set we're going to get this image. It's an handwriting. All right, so there are different types of handwriting. You can check the documentary of this TensorFlow data set. Now if you want to change the color, it's giving us purple and yellow. We can say okay, CMAP equals to what? Let's use gray. All right, so you're going to change the color font for us. All right, so this is one of the data set. If I want to look at the second one, which I'll say 1, and I'll go ahead and run it, so it's another data set, but let's stick to the first index. All right, so the next thing we need to do is to train our model, is to normalize our model by making it to fit to the to what we want it to be. Now in neural network, most especially in TensorFlow, is there's a pattern we need to do. We need to first of all divide this to give us to be from the arrays of 0 and 1. How do we do that? We say okay, train underscore images, all right, equals to train underscore images divided by 255, all right, 0.0. You can also say test underscore images equals to test underscore images also divided by 255.0. Like I said earlier, if you want me to give you a breakdown of the tutorial, please, I want you to comment on the comment section and let me know, and I will do a full tutorial on neural network from scratch. But here I just want to show us how possible it is to also train your model. You can train your image, you can train video, handwriting, whatever. It's going to convert it into an array of NumPy and going to make predictions for you. Now, what this image that you're seeing is it has an array of numbers 0, 1, 2 to 255. Now, if you want to doubt it, let's go ahead and print our train images. Can say okay, print. Go ahead and print our train underscore images. It's going to return an array of what? Of numbers. Have you seen it? So this is an array of numbers. This is a NumPy array. So what this means that this image you are seeing contains an array of numbers. That is how you can do it. So you can also say train let's say labels, all right, and you go ahead and run it. It's going to give you still an array, but we don't want it. What I just want to show you that this image you are seeing contains an array of numbers from 0 to 1. All right, so the next thing we're going to do, we are going to build our model. Remember I said we're using TensorFlow. The neural network is TensorFlow as a library or a framework for building this kind of project in neural network. All right, so the next thing we're going to do is okay, we call our model equals to, you say models, all right, dot, we are using sequential, all right, okay. Now we are going to make it an array. You say okay, we are going to have 4 layers, keras dot layers dot, the first one is flatten, all right, and you're going to say input underscore shape is going to be equals to what? 28 by 28. All right, so if I come here, okay, we have, this is the array, the input shape. The shape of this image or this data set is 28 by 28. There are some ones you have 32, 32 and 3, but we are working on what? 28. It's very important for you to also always check your data set to know the kind of the shape of your data set. So the first one we're looking at is the input shape of what? 28, 28. We're going to go to the next one. All right, so the next one is to say keras dot another layers, and this one we are going to look at dense. All right, and the dense is going to be 128. All right, it varies from 32, 64 and the rest. Everything you have here you're going to multiply it by 2. For example, if I go to my calculator and I say 28 times 2, it's giving me 56. Okay, if I go and say okay, 56 times 2, 112. Okay, so whatever you are having here as this 28 is going to multiply by 2 to give what you want. Okay, it varies from 32, or you can say 32 times 2, it gives you 64. This 64 times 2, all right, it gives us this 28. So this is how we got this 28, 128 that we are working with. So 128, and we are going to use that activation. Activation is equals to, what are we going to use? We are going to use the popular one, ReLU. Now, like I said, I won't be going deeply to this. You can check the TensorFlow documentary, or you can put on the comment section that you want me to give you a full tutorial to explain each of these layers and each of the concepts I am doing. So for now, I'm just going to build the TensorFlow model using neural network. So the next layer we need is keras.layers. Okay, layers, I misspell it here. Alright, layers dot, I need a dropout. Now, while you are working, I will show you exactly what you want this dropout stance, so that you not overfit your model. Alright, so, and the next and the last one, we say keras dot dense. Okay, this is the last dense we are going to work out, which is 10, because the classes of this is from the arrays of 0 to 9, so we need 10 of that. That's why we are having this 10. And the activation we need is there's what we call soft max, because we are doing multi-class classification, mode soft max. All right, so you go ahead and do what, and run this code. All right, let's run. Keras layers has not able to drop. Okay, I misspelled this, there is no, all right, dropped is dropped out. Okay, let's go ahead and run this. Dense. Okay, sorry, dot layers dot dense. All right, so we are good to go. All right, so the next thing we need to do now is to compile our model. Say model dot compile. All right, so we are going to use an optimizer. We're going to use Adam, and we're going to use our loss function is going to be space underscore space underscore categorical underscore cross entropy, and the metrics we're going to work with, and our metrics is going to be what, in array. Matrix is going to be matrix equals to an array of what, accuracy. All right, so let's go ahead and run this. All right, so our code is working. Now the next thing we need to do now, we need to fit in our model. Say model dot fit. Okay, what are we going to do? Say train underscore images and test and train underscore labels. All right, now epoch is going to be, epoch is equal to, let's use 5. Now this is the reason why we had to put this layer, dropped out layer, because if, for example, you can use 100, epoch means the number of times that this model is going to see or to run before it gives you the normal percentages. So now there are sometimes you can use 10, 20, 50, 100 depending on your data set. You can overfit and the model begin to misbehave. That's why we have to put this layer to drop out 0.2 to monitor our epochs. Epochs means the number of times this model is going to run to see. For simplicity, let's go ahead and use 5. I'm having this issue again. All right, so I'm asked to, I have 60,000 and here. All right, so let's just do model dot evaluate train test underscore images. underscore labels. It's not gonna give up because we need to work on this. All right, so we need to work on this. We need to fit in and try to see how we can correct this error to give us what we want. So just hold on as we correct this together. All right, so I've been able to correct the errors. So I wasn't working online. I needed for me to connect my internet in order for me to have what I needed. So I connected my internet connection, so I had to get what I wanted. So let's go ahead now and fit our model. Let's say model dot fit. What we are going to fit in is what our train underscore images and train underscore labels. Okay, and the epoch, I say the number of times we want to run this epoch equals to, let's use 5, and let's go ahead and run this. Model is not model, train images, train name model is not defined. Okay, let's run this. Okay, I'm gonna run all cells. Okay, so as you can see now, the epochs is running. All right, like I said, the epochs is the number of times that this model is going to see these images and the labels. So it's going to run 5 times for us. Okay, just wait. This is the number. Okay, now if you look at here, we use our loss function here. Started at 0.4872. It dropped to 0.1512, and it now dropped to 0.07. So, and the accuracy was what, 97% accuracy. It therefore means that we now fit in our train images and train labels to our model, and we say, okay, run for 5 times. Go ahead and look at this for the 5 times. We run 5 times. Now, as you're training, as you're looking at now, let the accuracy go high and let the loss function begin to go down. Now, if the loss function drops, accuracy increases. If the loss function increases, accuracy decreases. So now, model was able to run 5 times, and the loss function was 0.0701, and accuracy was 97%. So that is good. Now, let's go ahead and evaluate our model. If now, remember we had some percentage of data set for training, and we get some percentage for testing. We did not fit in the whole data set to this model. So let's go ahead and evaluate and see how many percent is going to give us based on our training. All right, let's say model dot evaluate. All right, what are we evaluating? We're evaluating on let's say test underscore images and test underscore labels. All right, so let's go ahead and evaluate to see the accuracy. Name test images. Sorry about that. Let's go ahead and run this. All right, so now we still have it at, here we had 97.80. Now we have 97.19. So it therefore means that our accuracy is at what, 97%. Let's go ahead and evaluate and predict and say, okay, we have imported our matplotlib for visualization. Let's say, okay, plt.imshow. all right, what are we going to look at? Let's look at test underscore images. All right, let's go ahead and run it. Let's look at the first one, and let's go ahead and run this. All right, so let's say cmap equals to what, gray. Let's use gray as usual. Cmap. All right, so this is it. So this is our test. It therefore means that the first in our test images is what, is number 7. So you can also go ahead and say plt.imshow. Okay, image show. What are we showing? Let's say test underscore labels. Alright, so now say we need the first one, and the CMAP equals to what? To gray as well. I will go ahead and run it. Shape for image data. What's that? Im show test level 0 CMAP gray. Okay, you can use test underscore images, and let's rerun this. It's the same thing. Let's use the first one, the second, let's see the second and run it. So this is true. So ladies and gentlemen, this is how you can build your model. You can also make predictions. You can say, okay, prediction equals to model dot predict our test underscore images. Alright, so I go ahead and call this prediction. Alright, so this is the prediction. Like I said, all these number you are seeing or images, it has a numerical function. So this is how you can successfully create or build your model using TensorFlow and Keras. And you can build your model using image, you can use video, you can do image classifier, image identification, and the rest. So like I said, I am very sorry for not posting for a long period of time because I was on a course on neural network. I want to become fully data machine engineer, fully with not just scikit-learn but also with neural network. So ladies and gentlemen, see you in my next tutorial where I will teach you the basics of TensorFlow and neural network. I hope you find use of this video. Please do well to share this video, comment, and also follow this page if you are seeing on Facebook. If you're on YouTube, please do well to subscribe. Let me know you are enjoying my tutorials. Encourage me to keep doing more. I am going through all day just to ensure that I come here and I give you step-by-step approach to how you can build your own machine learning models. See you in our next tutorial. My name is George. Please do well to follow, subscribe, and also put your comments on the comment section. See you in the next tutorial.